So hello everyone. I presume you guys are both here for object-oriented programming, the review session. So this will be a 2-hour session in which we go over most of what you guys have covered in the class. I know a lot of this class is kind of syntax and vocabulary, so we're really going to try to hone in on all the different words because I know it can be confusing. Some of them are kind of similar or they sound similar. Then we're going to go over different programming examples as well, similar to maybe some ones that you might see on your exam or that can help you think like how you'll have to think to solve problems on the exam. So let's get into it. So first we're going to go over the general structure of our program, since that's super important in object-oriented. So overall, as you guys have probably seen so far, one of the major first structural elements is a class. You can kind of think of it as like a blueprint in which the other elements go. And then we can have subclasses, we can have superclasses, and then from those different types of classes we can make objects, which are then the actual entities that we use throughout our programs. And then those objects themselves have variables that the classes describe. So to begin with objects, so they're defined as software bundles of related state and behavior used within programs, and they model real-world objects. So a common example that I've used in my sessions that you guys might have seen in your class is like a car, but if there's a real-life object, then you can make an object-oriented object for it. And then objects have state, which are their variables, and then they have behavior, which is described through their methods, which, like in a language like C, is essentially functions. So we'll use this car as an example because it can lend itself well to describing through state and behavior. So for state, we describe state in the form of instance variables, which is synonymous with member variables and fields. So if you hear any of those three terms, they all mean the same thing. And the state, or these instance variables, is specific to the object it's representing. So if we set a certain instance variable of this car to, let's say, 5, it's only going to be 5 for this specific car object. It's not going to be 5 for all car objects or all objects in general, just this specific one. And then state is, with these instance variables, allows for encapsulation. So we can typically use public methods like getters and setters to deal with private instance variables. Because you guys have probably seen that when you declare your class and then you have your instance variables at the top, they're all private. And so that's encapsulation, information hiding, making sure people don't have too much access to your information. And then we use those public methods with getters and setters to either get and return a value from a different class or to set and change a value of a different class. So if we look at our car example on the right, I posed the question to think of different instance variables for an object, because maybe on an exam, either of your professors could ask, what are examples of instance variables? Or, in this class, what are the instance variables? Something like that. So if you think about that, some examples could be string color, int speed. Maybe we have a person class, so we need a person object called owner. So any of these instance variables are valid. They can be a variety of types. So now getting into the behavior side of objects. So the behavior, or the tasks that we perform, are done through methods or functions, like I said before. And in order to call a method, we kind of follow this general format that I've laid out on the bottom left there, which is our object name, the dot operator, and then the method name. So for instance, a type of question maybe you could see is, how would you call the setSpeed method on the object myCar? So a common mistake sometimes people make is that they think if I'm calling a method that's in the class car, I should do car dot. But that's actually not for regular methods. That's for more of class methods. So here we do myCar dot setSpeed. And we're presuming, even though I didn't say that setSpeed required an argument, we passed 100 to it, because it just kind of makes sense. If we're doing a setter, it probably needs a new value in its parameter list to change a variable. Okay, so some benefits of objects that are worthwhile to note are they're modular, which means that they can be easily used and edited throughout a whole system or a whole program. They allow for information hiding. So as I had mentioned before, the instance variables are typically private, so that people can't know too much about your program coming in, and that's only for your knowledge and your control over the program. They allow for code reuse, and they also help with debugging, because since they are modular and they're kind of these independent entities we can use throughout our programs, it's kind of easier to debug, because if we have an issue with, let's say, the myCar object we had earlier, we can just edit myCar, or we could just delete or re-add myCar. We don't have to worry about the entire car class or every single car object. So to get into classes, so they're kind of defined as a blueprint to create individual objects. So in order to create that myCar object, we had a car class. And within classes, essentially all of the code you write is going to be within a class. We have interfaces which are a little bit different than classes, but typically every line of code you write is going to be in a class. And classes, you can write your own methods within them, or you can import other methods from other libraries. So as you guys have been writing your programs and maybe using like the ArrayList class, for instance, that's a predefined class, and you can import it into yours, so that way you can start using the methods in ArrayList. And so then on the right there, I kind of have a layout of inheritance, because we know different classes can inherit different methods from each other. So you can think of vehicle would be the broadest class, so it would be the tallest superclass. And then within that, a car would be a more specific subclass. And then even more specifically, a cool sports car could be a subclass of car. So cool sports car is only a direct subclass of car, but you can also see that since car inherits from vehicle, then cool sports car also inherently inherits from vehicle. So the general format for writing a class is you typically want it to be public. Public allows us to use this class anywhere in any other class or interface or program. And then you have to have the keyword class and then the actual class name. And just in practice, we always capitalize our class names. And that's helpful because then later in the program, if you see a word and you're like, oh, is that a variable? Is that a method? Is that a class? If it's capitalized, it should be a class. And then we have our curly braces, and then within there goes all of the code we want to write. So all the state and behavior through variables and methods. So for objects versus classes, because it can get a little bit confusing to think, hey, like what's the difference? Think of classes as a broad blueprint, so kind of like the car factory on the bottom left, and then objects being specific instances of that blueprint, so the actual car that came from the factory. So now methods. So when we're actually writing methods, the first line is called the method signature. And what's actually required in that method signature is the name of the method, the types and names of parameters, and the return type. So some valid method signatures I have there in red in the middle. You can see that they can have different access modifiers, which means the public or the private part, but you don't have to list the access modifier. And so, for instance, like in the last one where we just said void add driver, we didn't say public or private, so it's going to default to package private. And then we have to have a return type, so we have to actually know what the method is going to return after it finishes executing. And in the case that it's not returning anything, we do have to say void. We can't just leave it blank. And then we can call the method essentially anything, and then within the parentheses go any sort of parameters we have. And we can have as many parameters as we want, including 0. And if we have 0, you just leave it blank. You don't write void or anything. You just leave the parentheses blank. And then another keyword you guys might see is this. And the keyword this refers to the current object running in the method, or the current object being worked on. And the keyword this is especially helpful in an instance called shadowing, which is when an instance variable and one of our parameters has the same name. So you can see that in our first method in red there, we have a parameter called myCar. So let's say we also had an instance variable in the class named myCar. It would get kind of confusing, like which myCar we're referring to. And so that's called shadowing. And so if we use the keyword this, it allows us to kind of determine which variable we're working with. Okay, so a constructor is similar to a method. It's kind of like a specific type of method, but its name is the same exact name as the class. So for our car class, our constructor would have to be called car. And a constructor doesn't list a return type, and that kind of differentiates it from other methods. And it doesn't list a return type because the whole goal of the constructor is to actually make the instances or the objects of a class. So for our car example, the car constructor would actually be making our car objects. And since it's always going to be making objects of the class, we don't list any return type because the return type is going to be an object of the class. So for car, the return type would be car, but we don't need to write that. And if you don't explicitly write a constructor in a class, Java's still implicitly going to put one in there, like a default no argument constructor. But typically when we make a class, we want to make instances of it, and so it's good to write your own constructor so you can determine exactly what state and behavior is going to be associated with each object you create. So now we're going to get into an example where we can use what we just went over to code up an example class called house. And it's going to include a few different constructors because it's possible to include different constructors depending on maybe what the user wants to do at different points when they're making a new object. So I'm going to get into, is this a good size? Like, can you guys read this? Like this font size? Okay. So just like we had said before, when we're writing a new class, we should say public because we typically want it to be public. And then we need the keyword class. And we said we're making a house class, and it should be capitalized, the first letter. Then we have our curly braces. And now let's say that we want to have the size of a house stored, and so that would be in an instance variable. And like we had said, an instance variable should be private for encapsulation and information hiding. So let's say we want private int size, and int makes sense because the size is probably going to be an integer. And then let's say we also want to store the color of the house, so we can do private. Let's say we want to store it in a string, then color. And now if we want to make a constructor for house, again it needs to be public, and it needs to be public because the constructor needs to be called in any other class, because we're going to be making house objects not within the house class, but in some other class. And so since it needs to be accessible in a different class, the constructor should be public. So public doesn't list a return type because the return type is always going to be house, and then it has to be called house for it to be a constructor. Parentheses, and then we don't have to have any arguments or parameters to it. It just depends on our implementation. So let's say that we want to call a different constructor. So first, let's write a different constructor. So it's public, house, and let's say this one is going to have parameters. So let's say that it needs to, we want to set the size, and let's say we want to set the color. Now again, the size variable and the color variable that are parameters here are different than the instance or member variables up here. So we could have called these anything. We didn't need to call them the same names as this. But since they are called the same thing, this gets into the shadowing example I was explaining before. So in order to differentiate these variables from these variables, we use the keyword this. So we would do something like this.size equals size and this.color equals color. And when we say this.size, we mean this specific object's member variable size. So that refers to this one up here. So this specific object's member variable size equals the parameter size. And then this specific object's member variable color, so the one up here, equals the parameter color, so the one from down here. And so now let's say that we want this first no argument constructor to call this constructor down here, which is kind of a common thing where maybe a user's sometimes creating a house and they don't know the size and the color, so they're just not putting any parameters in. In order to call one constructor from another, we actually use the keyword this again, and then we just have to pass a size and a color to it. So we could maybe pass just like a number like that, and then a string in quotes. So if we called this constructor, it would automatically call the next constructor. And that's just a simple example of a class with multiple constructors. And if you guys want any of these examples again or want to see this PowerPoint again, I'll show you guys how you can access it. Essentially, it's on the Study Union WordPress. So if you go to the computer science section and you look for my name with object-oriented session, you'll be able to get a PDF of this PowerPoint again, so you can see all the examples, because I've also included the code in there so you guys can reference it again later. So instantiation, which is another super important term in this class. So instantiation is actually what allows us to create and then start using our objects. So the general format is class name, object name equals new class name. So the first class name, the one in green, indicates the type of object, which is the class it comes from. And then the blue object name is just an arbitrary name we decide to use for our object, and that's going to be the name we use to reference it throughout our program. Then we have our equal sign. We have the new keyword to indicate we're creating a new object. And then we have class name again. And so now this class name, since it has parentheses after it, it shows we're actually calling the constructor from a class. So this allows us to actually call the constructor, instantiate the object, and actually have a chunk of memory associated with this object so that it actually exists, so we can start using it and manipulating it throughout our code. So there's an important difference between the terms declaration versus instantiation. So declaration is essentially just warning Java, like, hey, at some point I'm going to have an object with this name of this type. But since it's kind of just like a warning or just kind of saying, hey, this object's going to exist, the object doesn't really exist yet. There's no memory associated with it. So in my example here, I have, if we just wrote vehicle car, we'd be telling our program, okay, you're going to have an object named car, and it's going to be of type vehicle, but there's no actual memory associated with it yet. I'm just telling you eventually I'm going to make this. So instantiating an object is when we actually make the instance, or we actually make the object. So that's when we actually have to call the constructor. So you can see then on the third line, I say car equals new vehicle, which means that we actually called the vehicle constructor, and now there's a piece of memory associated with the car object. So the car object really exists. It's really an instance. So now, another short practice problem. We're going to make another class, but this time it's going to be for shoes. We're going to have some different instance variables. We want to have a constructor, and then we're going to actually try creating a getter and a setter. So again, getters and setters are to actually manipulate those private member variables so that they're accessible in other classes. And of course, there can be a lot of different options. So we'll go over one in this session today, but if you guys are interested, you could always practice on your own or review the code again later. Because again, depending on your professor, you might have to like read through a class on the exam and say what it does. You might have to write some of your own code. You might have to debug code. So just writing your own code and looking through other complete classes can really be helpful. So we're going to get rid of our house example there. So again, declaring a new class, typically want it to be public so it's accessible anywhere. Keyword class, and then we said it was going to be for shoes. Remember that capital letter for a class name. So now we want to have a variety of instance variables, but they're still all going to be private since it's the best practice for information hiding. So we can say private string brand. Maybe we want to store a string that has the brand name of the shoes. Then maybe we want to have the size of the shoes. That should probably be an integer. And then we could have the color. Typically I always just put color in a string. And then maybe we also want to have the owner of the shoes. So that also can go in a string if we're just going to store a string of their name. So for our constructor, again, it should be public, no return type listed, and it has to have the same name as the class. So public shoes. And if we're going to make a no argument constructor, as I've done here, then any actions we do in here are going to just automatically be set for any shoe object we create. So anytime we call the shoes constructor, it's going to have to just automatically set certain default values that we put inside this constructor, since we didn't allow the user to enter any of their own arguments. So maybe we could say brand equals, it has to be a string, so we could say something like Nike. Size has to be an integer, so maybe something like 9. And then color, just another string, so we could say red. And then let's say we also want to just start off with saying the owner as well. So by default, all the shoes are going to have the same owner. And then I can just put my name in there for the owner. So now, since we've set these default values, so every shoe that's going to be created is going to have these values to start with, We probably don't actually want all of our shoes to have these same values when they're actually in practice. That kind of defeats the purpose of objects. So that's when we'd want to start using our getters and setters so we can start changing around the values. So let's say we want to be able to change the color of our shoes in a different class. We can't access this variable directly since it's private, so we would need a public method. So let's create a public setter for color. So it should be public. And since we're just changing a value, we're not actually, we're not returning anything, and so it should be void for the return type. And then typically a name that we use for our setters is just set and then the name of our variable. So you could say set color, and it's going to need to take in a parameter that's the color that the user set. So, or we don't want it to be in quotes, we'd want it to be called string, maybe C to represent color. Okay, and then all we would have to do in here is just set our private member variable color equal to the parameter, C equals C. So now we're able to set the color. We are able to change this private member variable from any other class just by calling this public method from that other class. And now let's say we want to do a getter for the color, so we want to actually be able to return and access that color variable that we might be changing around. So it should be public again. And then since we're getting a variable, it means we're returning it and going to be using it. So this should have a return type, and the return type needs to be the same as the member variable. And so if we're working with color again, the return type should be string. And then good practice is just to call it get, and then our member variable name, so get color. And since we're just getting it or returning it, we're not changing it at all, so we don't need any sort of parameter. And then all we're doing is we're saying return color. And then this will allow us, if we call the public method getColor in some other class, it'll allow them to access this private member variable color. So this is just a simple example with some instance variables and getters and setters. And the example I did there, I did get color, but I did set owner instead. So if you want to look at the example, it's a little different, but pretty similar. So now I'll go over some general syntax and practices that you guys have been learning and completing throughout the class. So assignment, this is pretty basic. It goes in with any programming class you do. You have to have assignment, setting something equal to something else so you can change a value. And then something to make things a little bit easier, you can do compound assignments like times equals or plus equals, so you can change a value and set it equal at the same time. Just saves you a little bit of room in your code. And then another interesting one that can kind of replace like an if statement or some Boolean logic is conditional assignment. And that's one that students don't always see a lot, so I like to go over just because it's kind of interesting and you might need to know it either in this class or in a future class. So with conditional assignment, essentially the first choice is assigned if the condition is true, and otherwise it's the second choice is assigned. So in our example here, we have x is 100 and y is 50, and so we're setting larger to one of two values. So in the parentheses, we have x is greater than y, so that's the condition being evaluated, and the question mark kind of shows us that, okay, so we have to evaluate if this condition is true. And so if the condition is true, x is assigned to larger, and if it's false, y is assigned to larger. So an example here, think about what would be the value of larger there. So as I said, x is greater than y, because 100 is greater than 50. So since that condition evaluated a true, the first choice is assigned to larger. And the first choice after that question mark was x, so it becomes larger equals x. So larger ends up being 100. Order of precedence. This is important if you're doing a lot of different math or calculations, just so that you can know when to put parentheses to have precedence and how your math is going to be executed. It goes into PEMDAS, just regular math, and the equal sign is always evaluated last. And so an example I have here is what would be the output from this example. And so this gets kind of interesting because one of the more confusing parts of like precedence or operators can be when you have a plus plus or a minus minus. so incrementing or decrementing, because it can go either before or after a variable. So it can get sometimes a little bit confusing of like, oh, when's that actually going to happen? So I'll let you guys look at this for a couple seconds, but you can see we have an initial value of j, and then we also introduce a value of x. And you can see that sometimes we're doing j++ or x++, but sometimes we're doing plus x. So you can think about when that would actually be evaluated and how order of precedence happens with that. So essentially, since we started off with j is 10, and then we did j++, that means j then became 11. So in our first print statement, when we're printing j, it's 11. And since we had set x equal to j after j was incremented, when we print x, it's also 11. And then we print x++. And sometimes students think like, oh, okay, we incremented x, so we should have printed out 12. But actually, it prints out the current value of x, and then it does the increment. So it's still going to print out 11. But if we printed out plus x, it does the increment and then prints it. So in the next, where we're printing out plus x, it actually prints out 13. So in our output, it kind of looks like we skipped 2 numbers, but really we did hit 12. We just never printed that value 12. And then if we printed x again, it just stays at 13. And just a small thing that can get a little bit tricky, sometimes it gets confusing when we should or shouldn't use quotes. So in our last print statement there, since we put x plus j in quotes, it's just going to literally print out the string x plus j. So if you're just trying to print out variables, you want to just have those variables not in quotes. Anything you put in quotes is going to be a string, and it's just literally going to print out whatever's in that string. Okay, and so then it's common to do a lot of different math and calculations in Java, and it's really convenient because there's pre-existing classes and methods that we're allowed to import and use that really help us with that math. So I recommend if you guys want to explore the math class API, the API is essentially a definition for every single class that's already been created in Java. So like if you were looking up like, oh, like what are the different methods for ArrayList? If you search Java API ArrayList, and the first Oracle document that comes up, you'll be able to see all of the constructors and methods that exist for ArrayList. Super helpful. You can do the same thing for math because there's a math API. And so some common ones that you might see could be like math.pow, which is for raising a power. You can do square root, you can do min, you can do max. And then you can also manipulate values using these methods. So you can start nesting them, you can add them together, different things like that. And that really helps you do some more advanced calculations without having to write all of the code to do a square root or a max or a min from scratch. So that's really convenient. And so you can see there for math.min and math.max, they take in 2 parameters since you are comparing what's the maximum or what's the minimum of them. But they are only allowed to do 2 parameters. So you can't just put as many in there as you want. So I posed there for you guys to try it, to think about how would you use the math.max method to find the maximum of more than 2 numbers, like let's say for 3 numbers. So when you think about it, we can't just put the 3 numbers in there. So we have to find a way to kind of combine 2 of them or to evaluate the max for 2 of them. So if we did that, since we're allowed to nest different methods, we could call math.max on x and y, which will then either produce x or y, depending which one is greater, and then pass that as a parameter to another math.max call and compare the result of that to z. So that's pretty convenient, and it shows that we can really start nesting operators, which gives us a lot more power and a lot more ability to do complex calculations pretty easily. So expressions, these consist of variables, operators, and method calls. And of course, you have to follow the proper syntax for them. And if you're just writing an expression, it doesn't have to be a complete statement or working line of code. So it doesn't have to have like a semicolon at the end of it. So some examples of expressions could just be like a variable equals 2 numbers or 2 variables added together, or comparing one value to another. So value 1 equals value 2. So you couldn't just write these really in your code because, like, for instance, the first one would need a semicolon after it, and the second one would probably go in some parentheses for like an if statement or like a loop or something like that. but an expression isn't a working line of code. It's just like a piece containing those bolded elements above. So an expression statement is then what actually makes an expression a working line of code. So something like my value equals 800, semicolon. And so a question I've posed to you guys at the bottom would be, would the line x plus y minus z equals 100? Is it an expression or expression statement, and why? And so actually with this one, if it was proper syntax, it could be an expression statement. But another common mistake that students can make is they want to put some of the math or like calculations on the left side of the equal sign, where really they should be going on the right side. Because we don't really want to be setting like x plus y minus z equals 100, because that doesn't really mean anything for like x, y, and z independently. It doesn't tell us anything about that. So we'd want to do something more like maybe x equals y minus z plus 100 or something like that. We don't really want to have the calculations on the left. That gets confusing and it's not proper syntax. So control flow statements. This, like the name indicates, allows us to control how our program executes, the order of operations, not the order of operations, but the order that things happen, and just overall controls the flow of the program. So you guys have probably seen all of these and used them to some extent either in this class or maybe an intro to C. So different loops, different conditional operators, like if-else statements, breaks and continues, they all help with the flow of our programs. So if statements allow us to make like a simple decision, evaluates a condition, executes code if the condition is true. If else then provides us alternate code to execute. If the condition isn't met, the alternate code can go an else if or an else. But once a condition is satisfied, even if we have a lot of like other conditions after the if that could have been satisfied, if one of the ones at the top is satisfied, we don't evaluate the rest. We just break out of it and continue with the rest of our program. So for a code example here, you could think about what would be the output of this code. You can see we have an if statement with an else if, and it's evaluating our variable x, which we had set to 50 initially. So if we look at this, we can see that both x is greater than 5 and x is greater than 40 do work. But since we said only the first true condition is going to be evaluated, that means the output of this code would just be hello, because since that first condition, x is greater than 5, is met, we print out hello, and then we're done with this whole like if block. We just go on to the rest of our program. So switch statements, these are kind of a nice alternative to something like if or if-else statements. They also allow us to make decisions. An important thing to note with switch statements is that you need to have that keyword break after each case, because if we leave out the keyword break, we could experience something called fall through. So how we had it in like the if blocks there, we said that, oh, if one condition evaluates to true, it just breaks out and nothing else is evaluated. But with switch statements, we want that to be the same thing, but if we don't include that keyword break, it's going to fall through and it's not going to be what we wanted to happen. So here I have an example of a switch statement. And so you can see we're just evaluating based on the variable x. And you can see that because we passed x as a parameter to our switch condition, which is what's in parentheses. And so we have case 10, which means that it's evaluating does x equal 10. And then we have case 5, does x equals 5. And then we have a default case. And it's always good to include a default case just in case none of the other cases were met. So if we're looking at this, we think, okay, x equals 10, so it should match the first one. Case equals 10, so it should print out hello. That's all it should print out, and then it should break out. But since we don't include those break keywords after the print statement in case 10 or after the print statement in case 5, we're going to experience fall through. So since case 10 evaluated a true but didn't have a break, it's just automatically going to keep executing everything until a break is encountered, which isn't encountered until the very last line of the switch block, which isn't really helpful because we were already done with it. Okay, and then we have for loops, just like we do in other languages. So we have our traditional ones where you have, where you set a variable equal to a certain value, like in I equals 0, and then you compare it to something, so like I is less than 100, you could have I is greater than or equal to 10 or something like that. And then you change the value of I, so you can increase it or decrease it by different amounts. And then you could also even have like a blank condition in the for loop, which not a lot of people know, but that is actually possible. But it's cool in Java because we have something called a for each loop. So that allows us to loop through collections more easily. So we can see there in the last line on this slide, I have an example of a for each loop, which is for, and then we still have to have our parentheses, and it's for string temp : names. So if we break that down, we probably have some collection, maybe like an array list of strings or a set of strings or something like that. And it's going to be called names. And so since names contain string, we know each individual object in names is going to be a string. So we're saying for each string entity in names, and we're going to refer to each individual string as temp. So for each string variable, we're going to call temp in names, and that's kind of how you can break it down. And the for each loops, or they're also called enhanced for loops, they're really convenient because they don't require us to know like the size of a collection in advance. Because if we were doing a traditional for loop, like the one at the top, we would need to do something like for I is less than names.length, or we would need to know when to stop so that we don't go past the end of the name, or past the end of names. So for an enhanced for loop, you can see we don't have any sort of counter, or we don't have to say like names.length or names.size, because Java is automatically going to start at the beginning of names, and it's going to continue until we evaluate the last name. So then while loops, these are also pretty similar to languages like C. And then we have the different alternatives. You can just do a while loop. So while a condition is true, you evaluate code. Or you can do a do while, so do certain code while condition is true. The difference is that the while loop at the top is always going to check the condition first, whereas the do while does the code and then checks the condition. So do while is guaranteed to execute at least once, since at least in that first pass, it didn't even check the condition, so it's going to have to do the code and then check the condition, and then continue executing if the condition is true. So then breaks and continues are also useful for control flow. So break gets us out of the closest loop that we're in. And if we don't want to break out of the closest loop, like if, let's say, we're in a double or triple nested loop and we want to break out of one that's 2 above our current one, we would need to use labels. So you can see on the top right there, I used a label called first to indicate that that outer while loop is called first. So when we have that break statement after the if we had just said break, it would have broken us out of that inner while loop, since that's the closest while loop. But since we used labels, it allows us to actually break out of both loops. And then the keyword continue allows us just to jump to the end of the current loop iteration. So while break exits out of a loop completely, current just kind of fast forwards us to the end of the iteration of the loop. And then if there's more iterations left, then it's just going to continue looping, but it skipped the current one. So that's pretty useful in a case like if we only want to execute code if maybe the counter is even or the counter is odd or this other certain condition is true. So you can see on the bottom right there, I have it where if the counter is even, so I mod 2 equals 0, which means it's even, then we just continue, so we don't actually execute any code. But if it wasn't even, if it was odd, it would skip that condition and execute the line j plus equals 2, and then it would just continue on with the next iteration of the loop. So cars versus strings. So in certain languages like C, for instance, we don't have a string variable type. We can just make like an array of characters, but it's really convenient in Java because we do have a string variable type. So that gives us more power over our programs because there's like predefined methods for our strings, and they're just easier to work with than having to make an array of characters every time. So like in a language like C, a character is a primitive type. So the primitive types are things like ints and floats and doubles. So those are just most basic variable types, whereas a string is going to be a more advanced type than a primitive type. And a character is just going to be a single letter. Again, if we wanted to have more than one letter, it would either need to be a string. We could make an array of characters in Java. That is valid, but usually it's just easier for us to use a string. And when we're doing assignment with a character, we can just use the equal sign and then set a character equal to just another single character in the single quotes. And we compare characters just like we would compare any other primitive type, so with that double equal sign. So just like how we could do x equals y, we can do for characters a equals b. So a string is now going to be a sequence of characters, so 2 or more characters. And a string, like I had said before, it's more advanced than a primitive type. It's what we actually call a reference type. The default value for a string is null. So if we just create a string and don't set it equal to anything, it's going to start off as null. And strings are also considered immutable, which means that they can't be changed once they're created. And in order to initialize a string, we could have something like string name equals, and then instead of single quotes, we have double quotes. So we always put our strings in double quotes. So for instance, double quotes Brigit. And so, like I had mentioned, since strings are more powerful than characters, since they're reference types rather than primitive types, it's really convenient because there's different methods that we can use to interact with strings. So for instance, if you were reading in an input file and maybe you were reading in all the input as integers, but some of those integers we want to consider to be strings. There's a method that exists in the integer class where we can do integer.toString and pass an integer to it. So we could pass either a number or a variable containing a number to convert it then to a string. So integer.toString 100 would convert the integer 100 to a string 100. So you could think it goes from just that number 100 to like 100 in double quotes, making it a string. And then we can also convert back from a string to an integer. So if we're reading an input file all as strings, and we knew some of those were numbers, and we wanted to convert those strings to integers, we could then do something like integer.parseInt, and then double quotes 100, which would then parse the string 100 and convert it to an integer. So again, if you're curious to see some other methods, or if you think you might need to use some methods in a program, or maybe you would see them on an exam, you could explore the string API. So again, just Google string API Java and just click on the first Oracle link that comes up. You'll see all the different methods that you can use with strings, because there's some other convenience ones too. Like you can have, like if we had a string s, let's say, if we did s.length, it automatically gets the length of our string. So unlike in other languages where you had to like loop through the entire length of a string, you had to start at the beginning and then keep counting and incrementing until you got the length because you completed the string, you can just do s.length. That's a built-in method. And then there's also a method like s.charat, which if you pass a number to it, will get you the character at that specific index. So if we did like s.charat0, it would get us the first character in a string. And if we want to combine strings, that's called concatenation, and you just do that with the plus sign. And in order to compare strings, since they aren't a primitive type, we can't do that double equal sign. So instead, we need to use the dot equals method in order to compare two different strings. Because if you use the double equal sign, it's going to give you some issues. So now, using what we just went over, I can give you guys a little self-test. So let's say you were given two different variables. So you're given int x equals 100 and string name equals hello. So I want you guys to think about how you'd write the code to create the string hello 100 from these two variables. And then I want you to also think about, is a string that's one character in length equivalent to a character? So if we just had like string x equals a, would that be equivalent to char x equals a? And then also think about, is the null string the same as the empty string? So these are three types of questions that might help you guys with your exam or could be similar to maybe something you'd have to think about on your exam. So I'll give you guys a couple seconds to think about that and we'll go over it. So let's start off with the first one. So for the first one, let's say first we have to convert an integer to a string. Since if we want to end up with a string and concatenate or combine two strings, we have to start off with both of them being strings. So we could store the string version of the variable 100 in like string 100, and so we use that toString method to convert the integer 100 to a string. And then we'd have our result where we concatenated our name variable and our 100 variable together. So then it'll just come up with hello 100. So for the is a one character string equivalent to a character? And the answer is no, because like we had discussed before, the character type is still going to be primitive, and the string, even if it just has one character in it, is still going to be a reference type. So they still behave differently. And then is the null string the same as the empty string? And the answer here is also no. So strings default to null, but if we want a string to be empty, we have to specifically set it to empty. So like in the last line that I have there, we would have to set it equal to just an empty set of quotes, because they're going to start off as null, so we specifically set them to empty. So now arrays. So an array is the way that type of collection, a way that we can hold data of the same type all together. The index of an array is going to start at 0, since we always start counting at 0. And in order to access a specific index or a specific element in our array, we use our brackets and then pass a number to it. And we're actually able to declare arrays in two different ways. You can have either the brackets after the variable type, so you could have string brackets myArray, or you could have the brackets after the name, so you could have string myArray brackets. Both will be valid and both will work. And then conveniently, just like how we had strings, we had a .size method defined. We have a .length method, or a .length characteristic defined for every array. So that way, you don't have to, again, loop through a whole array and keep counting how many elements it has. .length is already going to be a defined characteristic for it. And then similar to how a string was automatically set to null, all index values are already going to be initialized for an array. So if it's a reference type, all of the index values are automatically going to be null, whereas for a primitive type, they're all going to start off as 0. So if we had an array of integers, they would all start off as 0. And an array cannot be resized. So if we realize that, oh, we don't need some of these elements, I can actually get rid of some of them, I don't want it to be this big, or if it's like, oh, I want to add more things to my array, it needs to be bigger, unfortunately, we cannot change the size of an array once it's created. We would have to make a new array or delete the current array and maybe add its elements to a different array or structure. So an array list it's similar to an array and has similar functionality, but it's more advanced, and usually it's the optimal choice in Java when you want to have a collection. So it extends abstract list. So abstract list is its superclass, and it implements the list interface. So if you guys were curious, you could look up the APIs for those to see what methods exist for them. But an array list is really convenient because it's dynamically sized. So we had said for regular arrays, you can't change the size, but conveniently for an array list, you can change the size. So when you declare an array list, you don't have to declare the size. You just say what type it is, what class it's coming from, and give it a name, and then it's automatically going to grow or shrink as you add or delete elements from it. But with an array list, it cannot hold primitive types. So we couldn't have an array list of ints or characters or floats or anything. And similar to other objects, since they are a reference type, they need to be initialized. So we need to call the ArrayList constructor in order to actually have memory associated with our ArrayList and start using it in our program. So in the bottom line there, I have an example of declaring and then instantiating an ArrayList object. So our general format we follow is it's going to come from the ArrayList class. We say ArrayList. And then we have our angled brackets after we say the word ArrayList. And those angled brackets contain the type of object we're going to be holding. So in our case, if let's say we wanted to have an array list of strings, we would put string in those angled brackets. And then after that, just like with any other object, we just include an arbitrary name. So I just called this array list hi. It's not great practice, doesn't really tell us what the array list is doing, but it's valid. And then we have our equal sign, new keyword, just like with any other object. And then we call the array list constructor. And so it looks kind of long at the end, but it actually makes a lot of sense when you think about it, because when we're calling the constructor, it's basically just the class name again. So you can see our class name is ArrayList, and then specifically a string within it. So we just call ArrayList of strings, and then we have to have parentheses at the end, since that is a constructor. And yeah, so that would allow us to now have an array list of strings called hi that we could start dynamically adding to and removing from. And there's a lot of useful methods that are defined for array lists, which is really why they're usually the optimal choice over arrays, since they are dynamically sized and they have all these convenient built-in methods and a lot more. They're just really powerful tools, and they're a really convenient way to start manipulating data or combining data. So common methods that you guys might have seen so far or that you might use or need to know about would be something like .get, which allows you to just get an element at a certain index in your array list. If you did .add, and I just passed like an e to it, that would add an element named e to your array list. And if you specifically did .add IE, it would add element e at index I. So you can really get pretty specific with these. For like .remove I, you can remove an element at a certain index, or .remove O would be removing actually certain objects, so removing the first instance of an object. And then you can do something like index of. You can get the index of the first instance of an object you pass to it. You can do .size to, again, get the size or number of elements in it. .contains to see if there's a certain element in your array list. .is empty to see if it even contains anything. And then there's a lot more that you can explore within the API as well. So now wrapper classes, which you guys may or may not have seen, or you might have seen it and just not known the word for it. So you might be thinking like, okay, like array lists are really cool, but I use arrays all the time for int or for char. And you said that a primitive type can't be in an array list, so that doesn't seem as useful. So there's kind of a way around that, and it's through a wrapper class. So a wrapper class is what allows primitive variables to be used as reference variables. So example, for an integer, if we had int x equals 100, there's a wrapper class called integer, so with a capital I, and it's the full word integer. And we could make an integer object called, let's say, myx, and pass our primitive variable x to it. And that would allow us to then make an actual object or reference variable called myx that still has the value 100. And so since now myx, since it's of type integer rather than int, now it's of an object, it's not a primitive type, it's a reference type, and now we could put it in something like an array list. And similar to how like integer is a wrapper class for int, we have double with a capital D is the wrapper class for doubles. Character with a capital C is the wrapper class for a char. So then we can see that array lists really are useful for pretty much any data type, since we are able to use these wrapper classes. So now we'll kind of go over some like input and scanning things. So when you did any input, or you're reading in any files or working with any user input, you might have used the scanner class. And the scanner class is a text scanner that allows us to parse primitive types and strings. So it's essentially what can traverse an input file or some piece of input, and then allow us to use that data throughout our program. So when we're using a scanner on our input, we can consider that the input is broken into what we call tokens, or string tokens specifically. And to delineate, okay, like what's a token, like what's broken up, they're delineated through white space. So if we had like a text file that has a bunch of words, and they're all separated by a space like normal, each of those words is going to be considered a separate string token, since they are delineated by that white space. And in order to use a scanner object, we're just going to instantiate it like we do any other object. So its class is scanner, call it anything, so we could call it myScan, and then equals new, and then the class name again for the constructor, so equals new scanner. And you can pass different types of input to it. Usually we pass like the name of the text file or the input stream, so we could pass like input stream as a parameter. So again, we have a lot of different methods that exist for scanners. I've included some popular ones here that you guys might have seen or might need to use. So one, like your scanner name and then .next just gets you the next token. If you did something specifically like .nextInt or .nextDouble, it would specifically get you the next token of input as an int or as a double. If you do .nextLine, it'll just read an entire line, and then something like .hasNext is good to put in something maybe like a while loop condition or like an if statement condition, because it evaluates to make sure that there is a next element or a next line within your scanner. And so now for output, since we just went over a bit about input. So you've probably seen system.out.println most commonly for your output, but it is possible also to do system.out.print. The difference is that println prints a new line character after your input, so if you just did .print every time, it just wouldn't have that carriage return. And then it is also possible to do .printf, just like in C, but in this case, because it's pretty convenient in .print or .println that you don't have to use the format specifiers like in C, like %s or %c or anything. But if you do something like printf, you do need those print specifiers. All right, so now we're going to go over some more specifics about methods, variables, and classes. Okay, so we went over instance variables before, but there are both instance variables and class variables. So it's worthwhile to explore both because they are different. So an instance variable, so I'll start with that since that's actually what we had discussed earlier. So that's the latter part of the slide. So an instance variable is non-static, which means that it belongs to each individual instance of a class. So like how we had said at the very beginning, if we had an object called car and we had an instance variable speed associated with it, we said maybe like mycar.speed equals 10, then only the speed of your specific car is going to be 10. It doesn't affect the speed of any of the other cars, just the current car you're working on. And then another example I've listed there would be like an instance variable could be owner, because we would want each car to have its own specific owner. We're going to assume that not every car is going to be owned by the same person. And so then if we return to the top here, a class variable is different from an instance variable because you can think of it as the variable belongs to a class as a whole rather than the objects individually. And so we delineate a class variable by using the keyword static. So if you've seen that keyword static at all in those variables at the top, that means you're dealing with a class variable rather than an instance variable. And so since it belongs to the class as a whole, the value of this class variable is going to be shared by all instances of the class. So if we had this static class variable, let's say num wheels in our car class, and we set it equal to 4, that means every single car object we make is going to share this value of num wheels equals 4. None of the cars can have their own unique value of num wheels. They all have to share this one value of 4. So in general, class variables can be useful if we want something that describes the class as a whole, whereas instance variables are the ones you're almost always going to have in your program since they're specific to each individual object, which is helpful for describing specific state of an object. So now that we've discussed that, we're going to code up another example class. And this one's going to be a class called laptop, and it's going to have some different class and instance variables. That way you guys can see them in practice. So we're going to get rid of our example from earlier. So creating a new laptop class. We want it to be public, so it's accessible anywhere. Keyword class, name it laptop, capital letter. Our curly braces. And so now let's say we want to have an instance variable. So again, an instance variable is going to belong to each unique laptop object we make. So maybe something like the size of our laptop is going to be unique, because the size could depend on the model, it could depend on the brand, it could be dependent on what the user wants. So we want the size to be unique. We want it to be an instance variable. So we're going to make it private. It's going to be an int, and we can just call it size. And then let's say now that we also want to have a class variable for laptop. So let's think of something that all laptops share. So while they might be a different size, the number of screens a laptop is going to have is always just going to be one. There's going to have that one main screen. So we can think of that as a class variable, since we want each object to share that value. So we're still going to make it private for information hiding and encapsulation. But now, since we said it's a class variable, we have to add that keyword static. And then we have our type, so it's going to still be an int. And then we can say num screens, and we'll set it equal to 1. So now every laptop object we make will have its own unique size, but it's going to share this value of num screens. So they're all going to have a num screens equals 1. So now, if we actually want to start being able to make laptops, we should make a constructor. So it should be public, and then it has the same name as the class, so laptop. Let's say that we want to specifically set the size of each laptop when we're calling the constructor. So maybe we're passing the size as S. And then we could do something like size equals S. So every time we make a new laptop, the user has to pass an integer parameter to it that'll represent the size. And then we set the size member variable equal to this integer parameter. So now we could think about, let's say I thought about adding the method public void set num screens int number. And let's say I did something like num screens equals number. So when you first look at this, you say, okay, so like I've seen this before. It says set and then a member variable name. So this is a setter, which we use to change the value of a private member variable. And you can see, like, the syntax-wise, it's all correct. We're just changing a value, so we don't have any return type. We need this input parameter that has the value we're setting it to. And we properly set our member variable num screens equal to that parameter. But the thing is that we had said num screens is a class variable. It belongs to every laptop. So we don't want to start allowing just individual laptop objects to be calling set num screens, because then they could each start changing and have individual values of num screens, which defeats the purpose of our class variable. So we would not want to have this line of code here, or this method here, because it just doesn't make sense. It would cause us issues, since this is supposed to be a static class variable that isn't changed for each object. Okay, so constants. So constants allow us to start combining some keywords that you guys have seen, static and final. So we had just discussed that static makes it so that a variable belongs to a class as a whole, or in other words, it makes a value consistent across all objects. And the keyword final prevents a value from being changed later on. So it means that value is final, it won't be changed. So combining static and final will then make a value consistent and unchangeable, which are the two conditions we want to be met for a constant. So it makes sense to combine those terms to make something a constant. And just a normal convention, we name a constant with all caps. So that way later on in our program, if we see something in all caps, we know, okay, that must be a constant. So an example constant could be something like public static final, wheels in all caps equals 4. If we were doing something with like a car, we could assume that it's always going to have 4 wheels, so it makes sense to make that a constant. And so similar to how we had to differentiate instance versus class variables, we also have instance versus class methods. So an instance method depends in some way on an instance variable. So we need to use the dot operator with the object name. So this is just like the typical methods that you guys have used a lot and that we've gone over so far. So like when we did our myCar.setSpeed, that specifically set the speed for our car, so that was an instance method. So a class method is also going to have the keyword static used. So you can tell it's a class method just like you could tell something was a class variable. You see that keyword static. And for a class method, the behavior of the method doesn't depend on the instance variables. So instead of specifically having an object name dot method, we actually just say our class name dot method. So if we were doing something that just involved all cars in general and didn't involve any specific member variables, we would do something like car dot and then method name. Then overloading, which is another important term. We do overloading with methods and constructors. Makes sense since constructors are like kind of like a specific type of method or related to methods. So overloading is when different methods have the same name, but they differ in their order, number, or types of input parameters. So since they differ in their parameters in some way, that means these methods have different signatures, since those are components within the signature. So even though they're called the same thing, like they have the same name, their signatures are still slightly different since there's that parameter difference. So overloading is useful in the case that maybe the user has different knowledge or different requirements at different times they're calling a method. So maybe sometimes they'll be calling a constructor and know nothing about the input that they want to set to it, so they just have no arguments passed to it. And then maybe later on when they're calling a constructor, they know a lot about it. So they want to be able to instantiate their object with a lot of values. So it's useful to then have a constructor that doesn't take in any arguments, and then a constructor that takes in some or a lot of arguments. So a little example exercise to think about is if you wanted to overload a method like public void edit car in a couple different ways. Of course, there's a lot of different ways to overload methods, but you could just think about a couple ways that you would do it. And then if we compare the two method signatures at the bottom, think about if they are valid overloading. So keep in mind our definition of overloading was different number, type, or order of parameters. So let you guys look at this for a couple seconds and think about it. All right, so if we want to overload that first method, we need to change around the parameters in some way. So a couple ways we could do that is just if we just introduce some parameters, because it didn't even have any. So one could be an int and one could be a string. And then the two method signatures on the previous page were not valid overloading. So if I go back to it, these last two method signatures, so while they have different names of parameters, the names of the parameters don't matter. Those are just arbitrary names we gave them. We could have called them anything. What matters is their type, order, and number. So since we have a string and then an int, and then again a string and then an int, when the program looks at this, this isn't valid overloading because the parameters are still like same type, same order, same number of them. So we'll do another practical example of overloading. So we're going to add to that laptop class that we had just created, and we want to overload one of its methods. All right. So let's say, so I'm going to delete this set num screens because we said that was not a method we would want to include. But let's say we want to print out the size of our laptop. So let's write a method to do that to begin with. So you can do something like public. If we're just printing, we're not returning anything, so we could say void. And then something like print size. So we could write a line in here, system.out.println, size. It would print out whatever this integer value is here. But now let's say we don't necessarily want to just print out the size once. Maybe we're going to need to print it out a variable number of times, depending on where the user is in the program. So then we would want to overload the print size method to allow a user to specify to us how many times they want to print it out. So it'd still be public void, and still same name, so print size, but now something in the parameters needs to be different. So maybe we could take in some sort of counters, like int counter, that's going to tell us how many times we want to print out the size of our laptop. And so maybe we could do like a for loop in here for int I equals 0, I is less than counter, I plus plus, and then we're going to print out the size of our laptop for as many times indicated by this counter parameter. So you can see we have different code that we want to execute depending on the user's knowledge or their placement in the program. So we do overloading by providing different parameters in some way. Okay, so overwriting. So overwriting is a little bit similar to overloading, but it's still a fundamentally different concept, and they both start with O, so they also kind of sound similar to students, so it's kind of easy to like mix up overloading and overriding, so it's important to know the difference. So overriding is declaring a method or a field in a subclass that's already in the superclass. So you can see it's kind of related to overloading because it's like declaring something again later on that was already declared, but this one's different because it can be a method or a field instead, and it involves subclasses and superclasses and inheritance instead of just in being the same class. And so you have to have the same signature and access modifier on whatever new thing you're adding, or else it would be overloading. So overloading, we said we change the signature in some way since we change on the parameters, but in this case, we just want to like declare something again. So we want to have the same signature, because if we change up the signature, then it'd be overloading, which is a different concept. And if a method is final, and we discussed how the final keyword means that something can't be changed, we can't override it. So we can't declare like a new version of a method if it was said that it couldn't be changed, because that would defeat the purpose of using that final keyword. So to see it in practice, because sometimes it's just a little bit easier to understand it if we actually see an example, we're going to try overriding with our laptop class. And since it involves super and subclasses, we're going to need to make another class. So we're going to make a computer class to see this in work. Okay, so I'm just going to make it in the same file here. So let's say we want to make a class computer so that we can actually have a super class for laptop now. So declaring a class computer, we do public class computer, and then we have our curly braces. And so let's think about some things that a computer could have as instance variables. Every computer is going to have a weight, so we could make a private int weight instance variable. And then every computer is also going to have a brand, and that brand is going to be specific to it as well. So we want to have an instance variable for brand. So private string brand. And now let's say we actually want to be able to make these computer objects. So if we make a constructor for computer, public computer, and let's say since we don't want to start off with any parameters, it's just going to have to call another constructor later on. So we're going to use that keyword this, but we don't know what our other constructor is going to be because we haven't written it yet. So let's write that other constructor. So public computer, and let's say we want to initialize these variables for weight and brand. So maybe we're going to take in like an int w and a string b. So now that we know we're taking in an int and a string, we can pass in an int and a string here. So maybe like 100 and then Lenovo. And so now we can actually write the code in here. So if we want to set the weight variable, we could do weight equals w, and we could do brand equals B. And now let's say we want to do something like printing the type of our computer. So you can do public void print type. And then system.out.println. So we want to specifically say that we're in the computer class. So we can say I'm a computer. So we're not saying that it's a laptop, a desktop, a tablet, anything like that. We're just saying it's a computer. So it's just a general computer. Okay, so here we have our computer class. So now we want to work with our laptop class to make it a subclass of computer and maybe actually have it override something that's in computer. So if we go back to our laptop class here, since we want to say it's a subclass of computer, we have to have the keyword extends and then the name of the superclass. So computer. So we still have our instance variables here, which are fine. We still have these, our constructor here. But for our constructor, we'd actually want to add the keyword. We'd actually want to have this and then pass in, we can just have it be empty, but the first line of a constructor for a subclass needs to be a call to the superclass's constructor. So this allows us to call the computer constructor, because first we need to make a computer object, and then we can specifically do the things in the laptop constructor to make it a laptop object. So it has to be a computer and then specifically a laptop. So we can keep our our overloaded print size methods, but now we said we wanted to do overriding. So we have this method print type that said I'm a computer, but for our laptop, it'd be useful if we could say it was specifically a laptop. So we can override that method in the laptop class. So again, the signature has to be exactly the same, so it needs to be public void print type exactly again. And now within here, we could do different codes. We could instead do something like print out I'm a laptop specifically. So now we have successfully overridden the print type method that was originally in our computer superclass that said I'm a computer. So now specifically in our laptop subclass, it says that it's a laptop instead. So this shows that with inheritance and overriding, it's useful because you can start changing elements of a superclass to make them more specific or more applicable to your subclass. Okay, so it's also important to discuss access modifiers, but it's not too complicated if you just remember the general types that we have. So the access modifier just says what level of access a user or a different component of the program has to this specific component. And so if we don't include an access modifier for a class or a variable or a method, the default is package private. But if we specifically say public, that means that that element is accessible anywhere. So in this class, in a different package, in a different class, anything can use it. Private means that only elements of the same class can see a variable or method. So not even elements of a subclass can see it. And then protected means that an element is accessible by the same class and subclasses and classes in the same package. So it's less restrictive than private, but it's more restrictive than public. In general, the best practice is to make things as private as possible to do that information hiding and to prevent other users from having too much control over your program. So that's why we always make our instance variables private, but we need to make our methods and our classes public because those are the elements that we typically want to access in other classes or in other packages. So inheritance. So this is when we're able to create a new class using an existing class. So we just saw inheritance with our laptop and computer example. So the superclass is the broader class, and it's the class from which other classes inherit fields and methods. So before that was our computer class, since that was the broader one. And then a subclass is the class that's actually inheriting the fields and methods from the superclass. And so in our previous example, that was a laptop, since it was more specific and it was gaining things from that computer superclass. And a subclass is able to modify inherited methods through overriding, which is what we did through that print type method. And a subclass can also add its own fields and methods. So similar to how laptop had its own unique instance variables and its own additional methods, that made it specifically a laptop and allowed it to have additional behavior beyond what was just in the computer class. So inheritance is really useful because when you start having different classes that all inherit from the same superclass, you can see that they're all related. They all share the superclass's methods and fields, but they're also all able to be specific to what they need. They can add their own methods and fields and override the superclass's methods in order to add new functionality that they need. So in order to do inheritance, we have to use the keyword extends when we're declaring the class. So let's say we had a subclass person that was going to use the superclass human. We could have public class person extends human. So that says that person is going to be a subclass of human. It's extending human. And even if we don't specifically say extends and then a superclass, every class inherently does extend a superclass because every class comes from the object general superclass. So at the top of every class hierarchy, objects are always going to be at the very top, since all objects are going to be most generally some sort of object. And we can only extend one superclass, so you're only going to ever have one class listed after that extends keyword. But even though, let's say something like person or laptop could only extend that one superclass, that superclass can have many different subclasses. There's no limit. So the human superclass could have many different subclasses. The computer class could have many different subclasses. But each of those subclasses can only have one superclass. So then abstract classes, they're a different kind of class that's a bit more broad. And so they're still considered a blueprint like regular classes are, but now they're missing some sort of functionality that then makes them abstract. So when we're declaring an abstract class, we have to now include the keyword abstract. So you would say something in the declaration like public abstract and then your class name. And since they're missing some sort of functionality and we're considering them abstract, that means the class can't be instantiated. So we can't actually make objects of the class. And that kind of makes sense because if it's missing functionality, we wouldn't want to then be making these objects that are missing functionality, because then there would be issues in our program and not everything would be complete. So for instance, an example that I've used in my sessions a lot and that certain professors have used is if you had like an abstract class vehicle, you'd want to make that abstract because you don't want people to be able to instantiate just a broad vehicle. Because every vehicle needs to specifically be either a car or a truck or a motorcycle or a bike. We don't want to just have like this broad vehicle object being instantiated because that doesn't really make sense. So abstract classes can include concrete methods, which are just those regular types of methods that you've seen throughout these examples and throughout your class. So that's a method that has a signature and then it actually has implementation. So it has those curly braces and then a body of code or lines of code within that curly brace. But abstract classes, since they're missing some sort of functionality, that means they have something called abstract methods. So that's a method without implementation. So it's just the method signature followed by a semicolon. So there's no curly braces and then code provided for the method. So it lacks implementation. So in order to actually use these abstract classes to eventually create concrete objects, what we do is we create subclasses that inherit from these abstract classes, and the subclasses will provide the missing functionality. So subclasses will implement any abstract methods in their abstract superclasses. So if we had some abstract method maybe for like printing the name of a car or something like that, for the specific car subclass, it needs to provide a body for that printing name method. So that way it has all concrete methods, no functionality is missing, and then the actual concrete subclass can be instantiated and its objects can be created and used. So an interface is similar to an abstract class, since it's, again, something that's like a little bit more broad and different than just a regular class or blueprint for an object. And an interface specifies a set of methods that a class is going to need to implement. And similar to an abstract class, all of the methods within an interface are going to be missing functionality. They're all going to be abstract. Interfaces also cannot be instantiated. Instead, they're going to be used by subclasses again, and then if those subclasses are concrete, they can be instantiated. And if a class implements an interface, it means that it's agreeing to provide implementation for all of its abstract methods. And so the code is not going to compile and the program won't function correctly if it doesn't provide a body for all of those abstract methods in the interface. And if you want to declare a new interface, you follow the format public, keyword interface, and then an arbitrary name you choose for the interface. So very similar to how you declare a new class, just now use the word interface instead of class. So interfaces are different than superclasses because all of their methods are abstract. So we had said with an abstract superclass that it could have a combination of concrete and abstract methods, but with an interface, all of the methods are going to be abstract. So all of the methods are just going to be those signatures without bodies. But since they're all going to be abstract and they're actually all going to be public as well, we don't have to include those public and abstract keywords and our method signatures in an interface. We can just include the other elements of a signature. So that's pretty convenient because it just kind of cleans up our code and allows us to save some time from where we would just constantly be repeating that every single method signature was public and abstract. We can just exclude those words. And then also, unlike abstract classes, interfaces aren't going to have any instance variables. They're just going to be the abstract methods. So now to see this in practice, we're going to make an abstract class called friend. And we're going to kind of experiment with some subclasses that use this abstract class and see how the functionality works. Okay, so let's start off. We said we wanted to make an abstract class friend. So again, it needs to be public. But now since it's abstract, we add the abstract keyword. It's still a class, and then capital F there. So with abstract classes, we're allowed to have instance variables. So we could do something like, maybe each friend is going to have a name, and then the type of friend we're going to specify later at some point. Each friend's going to have a certain type. So when we want to first make a friend, so in our constructor, we, again, has to be public, same name as the class. Let's say that we're going to get a string for the name. So with every friend we make, we're going to first set its name, so name equals n. But now, let's get into the abstract or missing functionality for our abstract class. So maybe we have something like, depending on the type of friend or who the person is, we want to give them a gift or tell them something, but it's going to specifically depend on this type friend variable, which is going to be set in a subclass. So we could have something like an abstract method, public abstract, void, give gift, string g. Maybe string g can represent like the name of our gift. And then let's have another abstract method, public abstract, void, tell comment, and then a string that contains the comment. So since these are abstract methods, we had to include this keyword abstract and then a semicolon at the end of the method signature rather than what we would normally see, which is these curly braces and then code within the braces. And so since we are lacking functionality here and we have these abstract methods, we can't actually instantiate friend because it's missing defined behavior. And so we're going to need to define that behavior in subclasses of friend, so that way we can actually start instantiating some objects. So let's say that one of the specific types of friend is going to be like best friend. And so since this is going to now I'm saying we're going to agree to implement these abstract methods. We're not going to make best friend abstract. So we're going to say that it's going to implement all of the abstract functionality in friend. So I'm just going to write the class in this same file here. So we could do something like public class. It's no longer going to be abstract. Call it best friend. And since we want it to be a subclass of friend, it has to extend friend. So extends friend. Okay. And now we can also add, since this is a subclass, we're allowed to add new variables and methods as well. So we could also just specifically add maybe something like int years known, because maybe you want to also store like how long you've known this person. And now we can say public best friend. So make a constructor. We want to do string n, let's say, for name maybe, and then int years to set the number of years. And so now, since this is a subclass, the first line of the subclass's constructor has to be a call to the superclass's constructor. So we have to say super. And I might have said this had to be the keyword this before, but this should actually be the keyword super when you're calling a superclass's constructor. So we're calling superclass's constructor. We say super, and we see that the superclass's constructor, which is friend, requires a string. So conveniently, we have a string here, so we can pass n. And then maybe we also want to instantiate for our best friend the years known right away, so we could do something like years known equals years. Okay. And so next, since we agreed to provide functionality for these, we need to actually provide them a body. So it has to be the same signature, but just minus that word abstract. So public void give gift string g. Maybe we can like print out a message and say system.out.println, you get a, and then print out the name of the gift. So now we're telling the best friend what type of gift they're getting. And now we also need to provide the implementation for tell comment. So since it has to be the same exact line, you can just copy and paste that, get rid of the abstract keyword, and then say something system.out.println, and we could say you are, and then we'll print out the statement that we had said. So now we can see that we met all the requirements to make this a concrete class because we provided implementation for the two abstract methods. So now best friend is all good. It properly extends friend, and we would actually be able to make best friend objects. If we wanted to do something, if we wanted to make a different kind of friend, like maybe like enemy or acquaintance or second best friend or something like that, again, we would have to have it extend friend still, and we would have to provide implementation for give gift and tell comment, but they could be implemented in different ways. So while the signature would have to be the same, it would still have to be this public void give gift string g. We could put completely different code within here that would be specific to whichever subclass it is. So for instance, we did best friend, but something maybe like frenemy. We could do something different in the constructor. And then for give gift and tell comment, we gave them a different version of it that made it more specific to what this subclass was. All right, so multiple inheritance of type. So while we said that a class can only extend one superclass, it can implement as many interfaces as it wants. And so while it can just extend one superclass, that means that it's only going to be like very related in terms of state and behavior to one other class, but it could share methods with a lot of different interfaces. And so when we're looking at what type of object we've made, an object can kind of be considered to have multiple types because it's of the type of its own class. So in the example we just did with the friend class and best friend, a best friend object is going to be of type best friend, but it's also considered the type of its superclass. So it's also considered a friend object in general. And it's even considered the types of any of the interfaces it implements. So if we had best friend maybe implement the interface human, then best friend would be considered a best friend object, a human object, and a friend object. So it would have 3 different types in a way. And so when we get into these different types, it's useful because we could see then how different objects are related in our programs depending on which ones are of the same type in general or more specific senses. And when we're declaring or instantiating new objects, we can also kind of play around with what type of object we declare it to be. So at the bottom in red there, in the second to last line, I have car, my car equals new car, which is what we've been seeing. We can see that car is a class type listed on the left, and we're calling the car constructor. But if we said that the car class maybe inherits from the vehicle superclass or interface, we could have also said vehicle my car equals new car. So this is the first time we've seen now where the type of the object on the left doesn't match the name of the constructor, but that's okay, assuming the constructor comes from a class that inherits from the class or interface on the left. So if car is a subclass of vehicle, the last line is totally fine because my car is considered both a car and a vehicle object. So polymorphism is essentially how what we've seen so far with inheritance is that objects will specifically have the state and behavior defined in their own class, of course, but they're also going to have the state and behavior of their parent class or of their superclass. And so now this allows objects to behave in a way of different types of classes. And we're allowed to then treat objects of different types the same based on their common characteristics. So if they do share any interfaces or any state and behavior, they are going to overlap in some way. And like we had said before, an instance of a class can be the type of its supertype. And so another example would be an array list comes from the more general list. So we could declare something like list my list equals new array list, and that would still be valid. All right, so now we're going to get into different ways that we've been able to organize information, maybe different like containers and things like that. So a list is a way to have a collection of objects, and it's going to be ordered. So when you add elements to the list, they're going to stay in that specific order. And all the elements in a list have to be of the same type or need to come from the same superclass. And a list is also able to have duplicate elements and null elements. And similar to an array list, how we had the type of the elements in those angled brackets, it's the same thing with just a general list. So if we want to have a list of strings, list, angled brackets containing the word string. And then an iterator is a special object, so it comes from a class that's already defined in Java that allows us to traverse a collection. And a collection is just something holding related information. It's like a list or a set or an array list. So if we wanted to have an iterator that goes over strings, we could declare something like I have here of like iterator, the angled bracket string, a name for the iterator, and then you have to say the collection or list that you're iterating over, dot operator, iterator. And then a common method to call is dot has next or dot next, kind of similar to the scanner class that you can make sure that the iterator has a next element to look at and that it can then retrieve that next element. So a set is going to be an unordered collection of objects. That's unlike a list. But they still do all need to be of the same type or superclass. And with a set, they're only able to have one null element, and they can't have any duplicates, which kind of makes sense because since they're unordered, if we started having duplicate elements, it would get confusing and there'd just be too much overlap. And similar to lists or array lists, you have the type of the set within angled brackets. And then a map, which depending on your professor, you may have gone over or not, or you might see in a future class like CS2. But a map allows us to associate certain keys with certain values, and there can't be any duplicate keys. So if we just go to the bottom red line as an example, if we made a new map object based on integers and strings, it would allow us to associate certain integers with certain strings. So a broad example of a map would be maybe if we were reading in some input, and we wanted to see how many times each color appeared in an input. So we could have these key value pairs that had like a key, which is the name of a color, so maybe like red, blue, green, purple, and the value associated with it is how many times that color appeared. So if we had a value 1 associated with purple, purple only appeared in our input file once. If we had the value 5 associated with the key green, that means green appeared 5 times in our input file. So maps are a useful way to associate information, and they can also be useful for counting or something like that. And a specific type of map is a hash map, and a hash map is the most common one that you'll be using in practice. And then generics, kind of like a broad way to perform the same action on different kinds of objects. And you typically delineate them using a capital letter, oftentimes a T. And a generic method is going to be declared with one or more type parameters, and the type parameters will be input parameters and or return types. So an example method I have there at the bottom in red could be if you want to print an array, but you don't know what type of data is going to be in the array. So we could have some kind of method that we don't know what the return type or the type of data is going to be, so we use that capital T there to delineate, hey, like I'm generically printing out this array. Don't exactly know what type of data it's going to be, but I want to let you know like I'm going to be printing it. So you can see you have that T in angled brackets, and then in the actual parameter list in parentheses, we have T and then brackets to show that it's going to be an input array, but we don't know what type it is. So where we would normally say something like int and then brackets, or string and then brackets, we just have T and then brackets to show that it's just kind of like a generic array. It could be any type. And then we also have generic classes as well. And so a generic class is also going to be with those generic type parameters, typically with a capital letter like a capital T. And then you'll use angled brackets surrounding the uppercase letter after you have the class name. So to kind of make more sense of that, since that's a broad definition, if we were trying to declare a generic class called myClass, we could have something like public class myClass T, or public class myClass TV. So there are a few different options. And then some other data types that you guys might have seen in this class are stacks, queues, and linked lists. In other languages like C, you have to write all of the functions and code for each of these data structures every time you want to use them. But luckily in Java, like, you could still do that if you want to write it from scratch, but there are pre-existing classes and methods that you can use to declare and instantiate new stacks and new queues, and they have all of the methods pre-existing that you would need to perform the right functionality. And so these are just different ways that we can store information. Stacks, the most recent information that was added to the stack is going to be the information that's then removed. So they're considered LIFO, which is last in, first out. And then a queue is going to be first in, first out. So whatever was first added to a queue is going to be the thing that's added, is going to be the thing that's removed when you go to remove something. And then a linked list is a dynamic list of nodes, and it's another alternative to arrays. We're always looking for those alternatives to arrays, since arrays are static in size, which isn't super useful in case you want to be adding and deleting information. And if you want to see the functionality that exists, again, Google something like Java Stack API or Java Linked List API, and you can see all the ways that you can declare and then start using these objects. And then raw type, I don't think the classes have been going over this as much as of recently, but it's a data structure and objects considered a raw type if you don't specify the type of data it's going to be holding when you instantiate it. So for instance, we have a stack here, and we didn't say if the stack's going to hold strings or integers or another type of class we created. We just said stack myStack equals new stack. So that's considered a raw type because we didn't say what type of data it's going to be working with. And so if we want to make it less generic and we don't want it to have that to be that raw type, we want to have the diamond operator or those angled brackets then include the type. So if we want to have a stack specifically for strings, we should say that. We should have string in the diamond operator after that keyword stack. Okay, so now we'll get into a bit with user interfaces, exceptions, and threads. Depending on your professor, you may have gone over this a lot, or a little, or not as much, but they're still useful concepts to know, and you might need to know it in future classes as well. So GUI stands for Graphical User Interface, and it's essentially the part of the program that the user is going to see and interact with. It can be what makes your program interesting to look at or fun to play around with. And there's different libraries that are common. Swing and FX are probably the two that you guys have been using, but typically the professors focus more on Swing. So whenever you have a GUI, you have to start with a top-level container, which is kind of like the broadest container in which the other visual elements are going to be enclosed. And so the three top-level container options are a frame, a dialog box, or an applet. A frame can be the most common one for just a general GUI, because you can kind of just think of it as like a big rectangle that you can just place a bunch of other objects on. A dialog would be more for like a dialog box for the user to see and interact with. Then an applet is just another smaller alternative. And when we start placing objects on top of each other, so like within containers and next to other components on their container, this is considered a containment hierarchy. So similar to how we have superclasses and subclasses inherit from each other, when we start adding and nesting different visual elements, that's considered a hierarchy as well. And then no matter what type of GUI it is or what aspect you're working on, at least one element of your containment hierarchy has to have JFrame as its root. And each UI component can only be contained once. So if you already put a button on your dialog box, you can't also put your button on a different box or on the frame in general. It can only be contained once. So then event handling. So event handling ties pretty closely when you're having a user interact with your program or specifically with your GUI. So the event source is the actual action that took place. You can think of that as like the true event that happened, like a mouse click or a keyboard press. And then the event object is going to encapsulate some information about the event. So the object is going to like take whatever event that occurred and see what actually happened. So if it registers that a button was pressed, it's going to encapsulate which button was pressed and maybe at what time or point in the program. And then an event listener is going to actually monitor when the event occurs in your program. And we say that it listens for an event because it's what's actually going to detect when an event happens and then start processing other code that needs to happen when the event took place. And so an object is going to be passed to a listener when it happens, and then the listener is going to handle that event in some sort of method. So the listener is what calls some other method or line of code and says, okay, if this button is pressed, this color should change, this output should be printed to the user. So an action listener, so we have action listener. So action listener is going to be an interface. You can see that because we say implements action listener. And so when we see that keyword implements, it means that whatever we're working with is an interface. And so the action listener interface provides us different functionality that allows us to actually listen for events and then handle them appropriately. And when we actually want to work with an action listener, we need to add it to some sort of component. So you can see that the second red line I have on the slide is some component.add action listener, and then we pass it an instance of the class. Code. So there's a lot of different ways to do event handling. This is kind of just like the general formula for it, but depending on what your professor has said you guys should do for action listening and what the actual program involves, the steps may vary a bit, but this is just kind of like the general format for it. So then exception handling. So when we kind of handle things in general, it just basically means that some event, either good or bad, takes place, and the program needs to process what happened perform some functionality and then continue. So that's why with like action listening and event handling, it means that it looked for some action or event that took place and then called some code, executed that, and then continued on. So with exception handling, it's similar in that it waits to see if some sort of exception or problem took place, and then needs to handle that appropriately and either end the program or continue on the program in some way. So an exception is considered a runtime program error, so it happens at the runtime. It's short for exceptional event, and it's just something that's going to be disrupting the normal flow of instructions that we were expecting. And depending on the specific program and the specific type of exception, the program may or may not terminate, so it may or may not stop running. So there's different ways to handle exceptions, similar to how there's different ways to listen and handle events. And so two of the common ways are a try-catch block or throwing an exception. Typically for file reading or file input, we've used try-catch blocks or try-catch-finally blocks, where in the try, you have a block of code that tries to read in an input file, tries to open it, and then process it. And then in the catch, you have to deal with the case that the input file was not found or it was corrupted and couldn't be opened. And then the finally is an optional final block of code that can be included as kind of just last steps to clean up your program or to terminate it properly. And then a checked exception, so a different kind of exception, is something that occurs at compile time instead. So it could also be called a compile time exception. Kind of a way that you can remember when a checked exception occurs is that it starts with C. It's a checked exception, compile time, both start with C. So since it happens at compile time, it can't be ignored at the time of compilation, and it's something that the programmer needs to fix. So maybe like some sort of syntax error that the programmer needs to go and change. And then an unchecked exception is going to actually occur at the time of execution, so it's also known as a runtime exception. And these things can include like programming bugs or logic errors or incorrect usage of an API, so maybe you called a method incorrectly. And these can be ignored at the time of compilation. And then an error is actually different from an exception, and it's going to be going a step beyond what the programmer or the user can control. So it might be something like a Stack Overflow or a misuse of other resources, so something more advanced and complicated that the user can't really go and fix, like a syntax error or miscalling the API or something like that. But typically a program can't recover from it, so it's going to just have to terminate and be over with. So like I was explaining before, a try-catch-finally block is a popular choice for exception handling, oftentimes with reading in files. And so the try is going to actually enclose the code that could throw the exception, like opening a file that may not exist. And then catch blocks, there could actually be more than one catch block in the case that you might have multiple exceptions. Like maybe there could be an issue with a file, there could be an issue with another object or another event or something like that. And then finally is just always going to be executed after we exit out of the try block. And again, it could just be something that kind of like helps clean up your resources or helps just some final steps before terminating or exiting, just to kind of clean things up. So here is an example of exception handling with the try-catch block. So within the try, we try to open the file. So we could do like with our file input syntax that you guys have learned in class. And then within the catch, you have to have parentheses after the keyword catch. And within those parentheses goes the type of exception and just an arbitrary name you chose for it. So we could do something like file not found exception, since that would be the type of our exception if we were trying to do file input. And then we just called it E arbitrarily. And within the catch block, we could do something like print out to the user something like the file wasn't found, file couldn't be opened. You could maybe print out a stack trace, which would involve all of the methods or steps of the programs that had been called, so that the user can see like where the program went wrong and where it stopped executing. And then throws is an alternative to a try-catch block. So if a method doesn't handle a checked exception, which means that it doesn't have like that try-catch block to handle it, the method needs to be declared with the throws keyword at the end of the signature. And the throws keyword is again going to include the type of exception that it's going to be dealing with. And when a method throws an exception, it means that it postpones handling it. So instead of dealing it with it directly in that try-catch block, it throws it to something else so a different part of the program can handle it. So an example here of throws would be, let's say in main, we're working with either a file or just something else that could lead to an exception. If we don't want to have the try-catch block, we need to have throws and the type of exception. So for instance, file not found exception. So if we don't have either a try-catch block or throws in the method signature, our program's going to yell at us because it's going to say, hey, like there could be this exception that occurs, and if you don't have some way to handle it, like I don't know to terminate, I don't know how to handle this. Concurrency and multi-threading, this is more theoretical. I don't think you guys would have any like physical problem-solving questions with this. But essentially, concurrency just allows programs to have multiple threads of execution, and it allows different processes or threads to be executed at the same time to handle aspects of your program more efficiently. Because if everything was just going to happen one after another or not in an optimal order, the processor wouldn't be processing things efficiently, and your code would either be slower or just not running optimally. So it's essentially a way that we can allow separate programs to run kind of like in an overlapping way, but they're still tied together in some way. And then there's different thread states, depending if they're currently running, if they're waiting to run, if they're already finished, or if there's an issue. Like if it's blocked, it means that a thread is waiting for a certain resource, like maybe the use of a certain file that a different thread is already using. And there's also different status of threads. So depending on the priority of a thread, it may be computed sooner. So maybe if it's like a really important action or a time-sensitive action, it'll have a higher priority than other threads and it needs to happen first. And then there can be issues where if threads are waiting on resources that other threads are using, they can either get into a deadlock or one may starve. And then a monitor is a lock that's going to be held by one thread at a time, so that if a thread is using a file or another type of resource, it's going to hold the lock on that resource so that other threads can't use it, so they don't like overlap and use the same resource at the same time. So at the end here, I have about 5 different practice problems that are related to what we've gone over here. So there's different examples where you like write a class, you debug classes, you debug some code. And so these are all in the PowerPoint that's online. And so since we are at the end here, I'm just going to show you guys where you can see it. And these are also kind of just useful examples for you guys to go over on your own anyways. And so I have all of the answers in here as well. So it's like writing different classes, writing specific methods, finding errors in classes, things like that. So if you guys want to find this PowerPoint so you can use it, it's going to be on the UCF Study Union 2018 WordPress. So you can go to this URL or you can Google UCF Study Union 2018. And if you go to the Computer Science tab, it's going to be on this page. And it'll be object-oriented programming with Brigit, and then you can click and download the PDF here. But yeah, so that is our time for today. If you guys have any questions, I'd be happy to take them, but otherwise just make sure to fill out the survey. And thank you guys so much for coming, and good luck on your exam.